let's quickly take a look at what we've done last time and see if there's any questions. The very first thing before we start, I'm just gonna bring the notes we have done for last open file last day. So that's 13th. Oh, created 213th there. I'll fix it later. Okay, so we talked about modules. We talked about how compiler works, basics of object orientation. We kind of did a review. Also, we talked about different types. Essentially, a quick review of OOP345 with some fill-in-the-blanks type of things. So there's nothing over here to actually open now. Any questions from last time, last day? And I'm going to put over here, people at home, if you actually click on your name, you'll see that you can actually set your let me just set it over here. I'm trying to find something here. Just give me a second. So at the bottom of the page in big blue button, if you have a reaction over there, you can actually click over there and you can give me thumbs up, thumbs down, and things like that. So when I ask you a question, if I ask a question at home or something like at students, please give me a thumb up like that so I know that you understand, or thumb down that I don't understand, and then remove it with clicking on it again. Like that, I don't have to keep polling and asking you guys to respond to me. You can actually be quicker like that, and we can all see. We can all see your status and know that you're present. So just try and find it. This is interesting. All right, so I'm going to put this right over here like that. So I can see your lists, and you can see yourself over there too. And that's that. So one more time, any questions about what we talked about last time? All right, I went through your assessment test, kind of marked it and gave you some feedback. Take a look at it, and if you have any questions, talk to me, okay? Don't get disappointed when you see a mark over there. I think the highest mark was 7. And I think the average of all the marks is like 3 or 4 out of 10. You need to really start studying now. Don't procrastinate. And the fact that there were like 6, 7 people not even in class taking the test means that they think that the subject is a subject that you can actually just casually pass it, but that's not the case. You have to really participate. Anyways, take a look at the marks that you have, and let me know if there is anything you want me to help you with. So we talked about real syntax of main and understand what's going on. You good? All right. So when you write a command in a command line, when you write something like this, So any type of command line, if I write something like, if I put over here directory, let me see, what do I have? Sorry. So say, I don't know, program files. If I go over here and write a command and write dir, and then I'm going to write program files, and I hit enter, it issues the directory, the list of what we have in program files. So essentially, the value I have in front of dir is passed to the program dir. So this is an input to the program. Okay, so it's not asking you to enter the directory that you want to know. So when you're writing a command line, the values are, so this is the command, and in here, let me clear it. So you write the command or the executable name, whatever it is, then you pass the first argument and second argument and third argument and so on and so forth. So arg1, arg2, and arg3 are actually passed like an input to the executable that you have. And we want to see how we can do this. Okay? This has nothing to do with C++. This is actually C language. So this is something that comes with C language, but we've never talked about it, so we're going to talk about it now. So when you are writing, and to do this, you don't need any includes of any kind of anything. I'm just doing the include because I want to print something. Because this is the information that are passed through the command line into the, into the executable are literally built into the C++ structure, so that you don't need to include anything to do it within the language. And how it happens, it's like this. So IOStream using namespace std. Okay, so main actually receives arguments. So you can actually say over here, int arg. See, you can put any name over here, but it's a standard. Like, I have never seen any programmer write anything other than argc over here. It's the name of the argument. We can put anything, but don't put the normal name. Argc essentially means argument counter. It means how many things I see on the command line. So if I just issue the command like this and I hit enter, how many things are on the command line? One thing. And that's the name of the executable. So remember, you cannot have a command line with 0 things in it. It's impossible. Okay, so there is one thing over here, and that's the name of the executable. So that's the first thing. And the second one is an array of character strings. And how do we write that? We write over here character argv. And you do it like that. Oh, character pointer argv. And you do it like that, which means you have argv0 as the first string. Second string is argv1, argv2, argv3, and it keeps going like that up to argc, which means in here I can say something like for integer I set to 0 and I less than argc and I++. Then I can say, for example, cout, let's say I plus, or I by itself is fine. That's the index, so we know which one it is. So I'll put something like that. And then I'm going to say over here, argvi. So essentially, I'm going to print everything. If I just run this program, it's the debugger running, right? Did I run it? Am I running it? Yes. As you see, there is only, it says 0, and the big thing is over there. That's actually the very first, the name of the executable through the debugger of Visual C executes like this. So this is the name, the last one that you see, 03 January 13 exe. That's the one, that's the name of the executable, but it always uses the full path to execute it. That's why you see it says D column uses for that document Seneca, yeah, and it keeps going like that until it reaches to the name of the file. But what I can do over here is this. I'm going to go actually to that directory. So open folder in File Explorer. So that's the name of my directory, and January 13th, x64, because I have a 64. If you didn't have, it would have been just debug. Now, this is the name of the executable. Where is it? Oh, where's my executable? Right. Oh, I have another one over here. Oh, yeah. I made a mistake and I forgot to check mark that thing, and it created two of them. Let me fix that right now. I hate that. Give me 2 seconds. Let me just save this and close it. I'm gonna say cut. What do I have? Okay, in here I'm gonna say let's do like this. Cut. Paste it here. I don't like it with its nested directories. Looks confusing. Delete. That's better. So now I'm going to open this VCX proj. I'm back in business with only one directory, not two directories nested. So when I was creating, I didn't check that place the project into the same directory. Anyways, going back up. All right. So one more time, let me just compile and run it. All right. 3 years later, there you go. So it's the same thing, and this time it's only one January 3rd. And then it's x64, debug, and exe. So I can actually take that path too if I want. So I'm going to take the path from here, copy. Now I'm going to go to the command line. And in the command line, I'm going to go to directory D, and I'm going to say cd, and I'm going to put the directory. Okay, so this is the name of the executable that it created. Now, if I write over here 03 January 13, just like that, and I hit enter, you'll see that that's the only thing that is printed. Okay. Now, if I actually write over here 1, 2, 3, 4, 5. Now it's going to get printed like that. And this was the code, remember, that executed that. So essentially, every single thing that you're passing through your command line, it goes into your program using the arguments of main. And again, remember, these are strings. So your first thing to do at home, and I may give you that one actually, it's a good idea. Let's see how you can actually do it. You're 3, 4, 5, you're supposed to try and do it. So write a function, write an application, call it add. Okay? So write an application as practice at home, just to see, to understand exactly what does this do. Write an application at home called add, that you can say add, and put 2 integer numbers in here. Let's say, and when you hit enter, it's going to give you the sum of the 2. You think it's easy? Do it. Okay? That's all. Okay? You know that. So if I actually, so let's say if the program, I know where they are. So let's say I'm going to say that January thingy that I did. Over here, I can say 1, 2, 3, 4. And in here, I can say 5, 6, 7, 8, right? As you see, I know where they are. So arg1 has this one. Arg2 has this one. So you know where they are. And you have to make sure that argc is not more than 2 and less than. It has to be equal to 2 for this application. So if it's not, then you can print an helpline, okay? So this is a perfect practice to do this. And then try to find the sum of these two numbers and print it. Pardon me? The practice? Okay. As practice. Write an application and change the name of the executable to add.exe, or if you are on Mac, just put add. Because in, what should we call it? In Windows, when you have to call it .exe to become executable. But when you're on Linux, the file can be anything as long as it is tagged as executable. Then, so anyways, write an application and change the name of the executable to add.exe. Write the program. So if the executable is run as follows: add 1, 2, 3 and 1, 2, 3. Enter. As a result, it's going to show you 2, 4, 6. That is the sum of the two incoming arguments. Okay? You do that and you'll understand exactly how it works and what it is. You do that practice, you know exactly what these two do. Okay? So again, remember, argc is the number of, so in this case, argc is going to be 3. 1, 2, and 3 things over here. Arg0 will be add. Arg1 will be, let's change this one to something else. I'm going to say 2, 3, 4. So it's going to be 3. It's going to be 3. 3, 5, 7. Okay. So yeah. So add will be argc will be 3. Add will be arg0. 1, 2, 3 will be arg1, and 2, 3, 4 will be, and it should be any size number. Doesn't make any difference. Any valid integer. Okay, not only 3 digits. It could be 1 and 2. It could be 9,055,000. Okay, got it? So do that practice. That could be your quiz question. Okay. And again, it's OOP345, so you can use any. I'm telling you from now. Anything in C++ that you think you know how it works, you can use. I don't have to teach it. The catch is, if you do something, you may have to defend your code, which means in workshops, tests, and stuff like that, you write something that I see that I did not teach. I'm going to invite you. We're going to go online. I'm going to tell you, what does this line do? If you cannot explain, you get 0 in the mark, because that means you copied it from somewhere. But if you know how it works, good to go. You can do anything you want. So OOP345, sky's the limit. Okay? What you need to know. And the answer cannot be, so the program won't give you error. Okay? You can't do that. So because I had this once, I asked, why did you write this code? It says, so it wouldn't give me error. So you can't do that. That's not a good answer. You have to tell me exactly what it does. So it's open for you. It's a challenge for you to do. And people online, did you get the question? Give me a thumb up. Joseph has no audio. Other people, please. Spawn? Okay, so that's going to be your challenge, and it's very possible that you're going to have that as your quiz question. Okay, so check it out. Okay, so that's that. That's what we call it, real syntax of main. There is another thing that's going to be on your quiz, and it is not in your book. It's not in your in the text that we have. I'm adding it. Is the environment variables, which means so in here I'm going to say a arg c arg v.cpp. Again, this is not C++. This is C. So I may ask you a question that main arguments are a C++ feature. You have to tell me no, it's not. It's a C feature. Okay. There is a third argument. What's going on? Today something is fishy. Okay. All right. Yeah, there's a third argument. env. Okay, so what is, before I explain what is that, I'm asking a question that is, what is a C string? What is a C string? Victoria. Hello?
Can you hear me?
Oh, yes, I can hear you. What is a C string, Victoria?
A C string is an array of characters.
Uh-huh.
That has like an index that goes from 0 and up.
Yes, that's any array, okay. And
I don't
it
really
has
know what
only
else.
one feature. A C string has one feature that makes it different with a character array. A character array is exactly what you said. It's an array of characters with index goes from 0 and up. But what make a character array is a string to a string is?
No character?
It wasn't your turn. Yeah, but okay, sure. No, so Victoria, remember, the definition of a C string is a null terminated array of characters. Got it?
Got it.
All right. Thank you. So that's that. So remember, it's a null term. That's why you don't need to know what the length of a string is, because you keep reading the characters until you hit the null string, the null thingy, the null byte. That's how strings worked, right? And it was really disappointing. Well, I asked you to write an array for me, essentially, in the test. And people were doing string length to find out what is the length of a double array. That's disaster to me. Okay, it means, oh my God. Okay, so please, for those people who don't realize what string length is essentially counting the characters until you hit a null byte, because null byte is not a valid character ASCII code. That's how we found. So we are okay with this? Now, the env, the last one, the environment that I put, it's a null terminated array of pointers. A null terminated array of pointers that are character pointers. That's why it doesn't have an argc. Over here, argv has an argc. So in this one, it tells you how many are they. In env, there is no count. Each one of these is a pointer to a string that is an environment variable in your operating system. And you have to 111 print it until you hit the pointer that is null. It's not a null terminated array of characters. It's a null terminated array of character pointers. Are we okay with this? So essentially, if this is your EMV, I see people are looking at me like I'm nuts. Okay, so if this is your EMV. These are, each one of these is a character pointer, okay? And then you have a pointer called ENV that is pointing to these character arrays. Okay? Because each one of these is a character pointer, and this is a character pointer array, therefore the type of this one, so if you have an array of integers, what does it point to? What points to it? An integer pointer, correct? Now, if you have a character array, what points to it is a character pointer, right? Now, if you have a character pointer, what should point to it? Character pointer, pointer. Okay? So this one, like that one, argc is the same. So this one is a character pointer, pointer. Okay? And each one of these is a character pointer, which means when environment variables that you want to look for, they all scattered everywhere, like that. Each one is a variable with a value, something like that. And these cells, one by one, are pointing to them. And how do we find out that we are at the end? When the last one is pointing to nowhere. The last one is null. When it points to nothing, you stop. So you have string, 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 stop. Okay? That's how it works. So we're going to come to pointer review, and we're going to go through all these things. Pointer to pointer, pointer to pointer to a pointer to a pointer, pointer to a pointer to a pointer to a pointer to a pointer. They're all the same. I'll teach you how to digest that, okay? So, yeah. So let's clear the screen for now. So what I need to do over here to see what environment variables are, I'm going to say over here for integer j set to 0, or I'm going to call it e. E set to 0, and e, and env, e. E being not equal to null, and e++. So what I'm saying, start from e being 0. If enve is not null, continue the loop. And it keeps going until it hits a null and stops. Okay? So now I can print them one by one. I can say cout e and put over here a column or something like that, and show the env, and get ready for this. It's going to be a long one. So if I run this, this is what I'm going to get. Take a look. So the first one is the name that I have because it's only one argument. This says all user profile is C column back program data. App data is users, FARDA, app like roaming. Common program files is that. And you can keep coming. Computer specification is a Windows 32-bit and cmd.exe. That's the terminal name. So if you want to know what a terminal name is, that's what it is. Drive data keeps going. Home drive is C. Home path is this. And you can even go to, it comes to path. This is all the paths that I have set that it searches into. There you go. Processor architecture is AMD 64. Processor identifiers, Intel 64 family 6 module, yada, yada, all the specifications of the CPU. Processor level is 6. Revision is that. So it goes through all the things that you want. Anything you want to know about the operating system is in there. And now that I'm logged into Matrix, I can actually try it over there too. So in here, I'm going to go cd OOP345 if I have it. Do I have it? 345. Okay, so I'm going to say make directory temp, cd temp, nano args.cpp. Okay, now I'm going to come back over here. Where's my Visual Studio? Visual Studio. Where is it? Oh, there you go. Okay, just going to copy this, copy, go back in here, paste, Control X to get out, save yes, g++ args.cpp, args.cpp, okay, and I'm going to say over here a.out, so the name of the executable is a.out, and I run it, and this is what we have. So as you see, the name of the executable is a.out, SSH agent is this, I don't know, keep going. Host name is matrix yada yada. So, let me see. Shell is bash. I want to find interesting stuff. Log name. You want to know who is running your program? That's log name. For that.soliman. So you can find everything about your application right in here, about anything that you want. Okay? So they're all in here. All right? All the environment variables are set in, so you can actually look for them. All right? And remember, it comes as one C string, which means one C string, which means the C string holds all the numbers that you see, 28, let me just go over here so people at home can see it too. So all the things that you see, 34, this is what I printed. This is what you have in here, you see? From here to here, it's all in one string. So if you want to find out what his log name is, you have to look for a string that starts with log name, then go up to equal sign. After that, copy everything, and that's your environment variable's value. Second practice. Again, a question in your quiz. Write a program called find env. The program works as follows. This is an example. So in here, I'm going to say find env environment. So in here, env environment variable, enter. Prints a help message if argument is not provided. Prints the value of the environment variable if found, or env variable not defined message if not found. Okay? So for example, if in the previous program, if I run the program as env find, and I write over here, and it should accept lowercase or uppercase. So I can write it like this, and it should match it with log name that is all capital. You have to write it yourself, write it that way, okay? And if I hit enter, the answer for it should be fardat.solimander. If I'm running it, of course. If you're running it, it's going to be your user ID, whoever user ID, okay? Okay? And that's actually a very useful thing to keep it in your matrix for different things that you want to check. You want to see what is path? Write phi_dmv path. It tells you what the path is. Or anything you want. Okay? It's got to go on internet. All right. Are we okay with this? All right. RBNI. So this is the second one. BENV.cpp. Any questions down to here? People at home, are we good? We are actually getting reduced. The number of people are reducing at home. Now it's only 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 people in class, and we have 40 people registered. That's how serious it is. I have to actually send a message to everyone. Yes?
I'm sorry, I'm not sure if I understood the pointer to pointer part.
We have 2 weeks on pointers. All different types of pointers. Don't worry about it. Okay? No, it's actually good. We have smart pointers. Okay, like smartphones, we have smart pointers in C++. We're going to actually code it so you see how it is. We have pointers in C++ that you create, and then you do dynamic memory allocation in it, and you don't need to delete it because it knows how to delete itself. When the time comes, it deletes itself, so you don't have to worry about allocating in the end. So we'll come to shared pointer, unique pointer, all these good stuff. So get ready for it. All right. That's that. So, and just to make sure that I want to see how many people actually will watch this thing. I want to really have a stat over here, and I want to report it to the chair. So anybody who's hearing this, please send me no, don't send me anything. Please go on Microsoft Teams and send me a private message. In that private message, write OOP345NAA, I was present. Okay? Anybody who can hear this. Okay? Not now, whenever you have time. Okay? Because I want people that maybe somebody wants to listen to it afterwards. So I want to know actually how many people out of 40 is going to listen to my lecture within a week. And that's a good stat to talk about this flex classes that we have. Okay? So a private message to me, and simply write OOP345NAA, I was present. Okay? Thank you. And I'm not writing it, so I want to make sure that people actually listen to the lecture for this. All right. So that's that. People at home or online, you heard me, right? Give me a thumb up if you heard me. Fantastic. All right. Okay. So it's good. Let's continue. We were talking about statics, right? So let's actually go through statics and see what statics are. We talked about static variables. Okay. So static variables are variables that we mentioned that the lifetime of them is global, but the scope of the visibility is limited within its scope, which means I can write a program like this. I think we had some stuff over there. We had an example last time, but I'm just going to write over here int val, okay? And in here I'm going to say static size t s, and I'm going to set it to 0, okay? Then I am going to say s, I'm going to say return s++. You see that? So if I write it like this, and I write a for loop over here, we don't need this actually, let's take these out. So if I write over here for I set to 0, int I set to 0, I less than, what do we have? 10 and I plus plus. If I write over here C out, val, and L, okay? If I run this program, obviously what I'm going to see is all zeros, right? Why? Because every single time that this function is called, S is getting created, initialized to 0, the value is returned, and afterwards 1 is added to it, and then S dies. Are we all okay with this? What is the name of this scope? What we call this type of scope? You can call it 2 different names. Block scope or function scope, right? This is what we have. It's block scope or function scope. So now I'm going to write the exact same thing, and I'm calling it sval. Okay? And I'm going to write the exact same code. I don't like it like this, because what is the scope of I? It's block scope, right? But if it's an old compiler, depending on the compiler, it may be different. Some compilers long time ago, when you created int I over here, after line 15, I would have been visible to everything. So it's not backwards compatible. That's why if I want to use it like that, I bring the integer out to make sure, or I put int I and j. Otherwise, it won't compile. So I, okay? That's better. Now, in second one, I'm going to call it sval. So when I run the second one, you'll see the difference between the two. Oh. What happened? Oh. Stupid compiler. Okay. There you go. And as you see, the second one actually keeping its value now. So you can actually, so the lifetime of the static variable remains the same. It won't change. Okay? And it keeps going over and over. Okay? That's the difference. So static variables and regular variables, that's the difference. Are we good? Now, let's talk about static methods. What does it mean? Static member variables and static methods. We need to understand what they are too. So this is static variable. We know exactly what it is. And it comes in handy in many, many different cases. No question about it. Okay? Are we good at home? Rohit, are we good? Wiki, wiki. Wake up. Rohit, you there? You're not? Eh? Okay. Anyways, there we go. Probably sister is calling, come on, you're a prophet. Anyways, so that's that. So that's your, yeah. With classes, statics are a completely different ballgame. Because in here you have a function. A function is one function, right? Which means it's not going to get instantiated to more functions. It's a standalone function, and the static value. By the way, again, this is not C++. This is C. It has nothing to do with C++. But the next one is C++, which is essentially classes. So if I have a class over here, whenever I give an example of a class, I put container, because container is a very easy thing to contain something. So whenever I write example, I call it container. Not that means something specific. It's just a good sample. So this one is containing an integer. So now if I say over here integer mval, and I set it to 0, now, and then I'm going to come over here and do public, and I'm going to say container container, and I'm going to create a default constructor over here. I'm going to say mval plus plus. And in a destructor, remember from OOP345, we do not have, I would never want to see you to write a destructor that is not virtual ever in your life again. Okay? Anytime you are writing a destructor, it must be virtual. Can somebody tell me, did you already answer? Why?
You have to have an implementation. Oh, you have to have an implementation.
No, it's not because of that. By the way, destructors must have implementation. You cannot create a pure virtual one. Why am I making it a virtual? Do you know? Give me a second. Give me a second. Cynthia, how about you? Do you know why a destructor has to be virtual?
Hello, can you
Hey.
hear me?
Oh, yes, I can hear you perfectly. Go ahead. Do you remember?
I think it's called the virtual destructor because so it ensures that the correct destructor is called for the correct derived class in like polymorphic behavior.
Yeah, that's the definition of virtual, not destructor. So you're kind of on right track. So a virtual method of any kind, when it's virtual, it guarantees that the latest version of it is going to get called. Having said that, Cynthia, why do I always need to have my destructors virtual? Think. If you don't know, I'm going to pass it to the gentleman over here. Should I pass, Cynthia?
Is it so that it ensures proper cleanup every time?
Yes, you just got 1% for your midterm. Okay? Remember, you have to remind me of all these bonus marks. I do that all the time. When somebody answers something important, I give them like a percent or two, and it really comes handy. So your midterm, you're going to have 1 extra percent. Remind me of it. So that guarantees that if container is ever inherited into another class, no matter how you refer to it, you're not going to have memory leak. Because always the destructor of the most recent implementation will be called. If you don't do that, if you don't make it virtual, and you have a derived class pointed by base class, and you delete the base, the derived class will be leaked into memory. Or when you make the destructor virtual, no matter how it is destroyed, the entire object, base and derived, will be deleted. That's review from OOP345. This should be, you should think that the syntax of a destructor is virtual destructor. Always. Make it a habit. Always. You look like a question. Yes.
So it's saying that there's like, because I think if I remember correctly on OOP, it's like we have to the way I'm sorry, but the way I remember it, few months. So it's like we always have to start our destructor from the latest created,
Yes.
right? So when we
You do that, you guarantee
it doesn't matter. Like
it doesn't
will
matter. It's
automatically-
always the latest. Automatically latest will be called, because that's what virtuality does, right?
Yeah.
It always guarantees that the latest version of the method is called.
Up to the oldest, sir.
Yes. All right. Okay. All right. So thank you. And thank you, Cynthia. Okay. So now that we have done this, I'm going to say over here mval minus minus. Okay. So in here, I'm going to say int how many? Okay? Now, if I write something like this, we know that it's not going to work. I'm doing it exactly like the other one. So in here, if I create, say, container C10, okay, and I go C out C dot how many, That is funny. I'm hungry, that's why I see menu everywhere. Yeah, many, how menu again? How many? C dot, how many? I can say C1, C2, it doesn't matter, okay? If I say how many over here, the value will always be 1 because it creates it and it destroys it in the destructor, right? I can actually do it like this too. I can create it dynamic. So I can say is equal to, I can say C is equal to new 10, new container 10. Oh. Okay, that's essentially the same effect. But this has memory leak. When it finishes, it's gonna, okay? Are we okay? And when I delete it over here, the destructors are going to get called on what? Now, I want this to be static, but you have to understand what is a static member variable is. In a function, a static variable, when we had the previous function that we had, the static variable gets initialized only once. So line number 8 happens only once. S gets created, it gets initialized to 0. Afterwards, when the function is called, the good old S will be added by 1 over and over and over. Therefore, the value is not going to go away. So what does that mean for a class? For a class, when you make a variable static, first of all, you cannot initialize it anymore, and I'll explain why. Unlike regular variables, a static variable cannot be initialized. Number one. Number two, imagine I have instances, and in here I'm going to have another thing. So let's say int some m attribute, okay? When I create instances of this, so let's say this is one container, another container, another container. So I have 4 containers over here. If I have 4 containers, then obviously I'm going to have 4 m attributes. 1 m attribute, 2 m attribute, 3 m attributes, and 4 m attributes. So the attribute is this one. Are we okay with this? But when you create a static variable, the static variable, like the function, gets created only once. If it's only once, which one does it belong to? No one or all? Which means mval would be this one. Got it? So they all have access to it. Because of that, none of these can initialize that because you don't know which one is coming first. You have 4 different objects. Which one should take care of initialization? Functions, easy, because function gets called once first. That's the time that you initialize it and you create it. With classes, each one of them is a separate initialization. You can't do that. That's why all the static variables must be initialized outside. So out here, right under the class, I have to mention int container, mval equal a container now. This is correct, which means the static variable will get created separately on its own outside, and it is accessed by all of them, which means the first container that gets created adds 1 to this. Then the second one adds 2. So essentially, you can count how many instances of the object is created. You follow down to this point? Okay? So now if I actually run this, you will see that actually 10 objects are created. You see that? Because an array, when it's created, 10 times default constructor is called, right? So 10 objects are created. Now, what if I want to know how can it actually, how can we actually see if there is none created? It is impossible, right? Because first you have to create a class and then call its method, right? First you have to create a class and then call its method. If I want to see how many created, in this case, it's never going to be 0. Because the object must exist so I can call its method, right? Right? Because of that fact, you can actually make the function static too. Now, obviously, this cannot be const anymore, because a static function does not belong to any, and it belongs to all. So a static variable, a static method, see, a static method, because it's only one, so the static method, let's give it a yellow color. So if this is my static method, okay, the static method is created separate from each instance of the class. It's a method that exists outside, but belongs to each class. So the static method, because it's only one, cannot change a regular attribute. Because in here, if I say m attribute is equal to 2, there are 4 of them. Which one? It's one too many. It doesn't know which one to change. That's why static methods can only access static attributes, only. But regular methods can access anything. Okay? Now that I have this, I can not only call how many using the object name, I can also call that using the class name. So I can actually do something like this. I can actually write over here container how many after deleting and I can have this one over here and say before creating. Okay? Instead of this one, I could have called the one that accesses with class 2. But remember, only static methods can be called using the class name. Because static methods, they don't belong to the object. They belong to the class. Actually, when you go to other languages, I think it's C# and Visual Basic and things like that, they call static attributes shared attributes. And they call static methods class methods. Because they should be called by class name, not by. You can call it by object. It doesn't matter. Because remember, object can access the static. Static cannot access the object. So now if I run this program, you will see that it actually shows the value 0 before. You see, before creating, I have 0. Then I have 10 of them. Then I deleted the 10. Now I have 0. And this is a good time to check something else. What if I don't put the square brackets in here? What's going to happen then? Let me see. Why did it do that? I have so many things on the screen, I can't see what I'm doing. Let me clear that out. It shouldn't give me. Oh. Port. It shouldn't give me an error. Wait for it. It needs time to. Cool. If it was old times, you would have seen 9 over there, and you had memory leak. For some reason, it's actually crashing. I have no idea why. Yeah, compiler got wiser. As compilers are getting better, and it could keep going forward, because you could do that and it ran, right? Because it was 10 containers, and you used to be able to delete a single one. I would give you memory leak. Remember? Now this is the first time, actually. Probably I have an update in a compiler. But anyways. Actually, I don't mind running that on matrix and see what happens. Oh, and we need another thing over here. Make sure that it compiles. Import. Wow, this thing is still on. Okay. End task. Oh, it's gone. Okay. This is going to get closed. We don't. Oh, that's a command line. We don't need it. Let's go over here. Nano static. That's CPP. G++, static, CPP. Oh, PP. Shoot. Static. Move. Static to CPP, not PP. G++. Oh, these are warnings. That's okay. So A.out. Nah, this one is actually crashing. I'm happy. Okay, good. Crash is good. If it crashes, I'm happy. Anyways. But anyways, you know what I'm talking about, right? So, yeah, so if you can actually count how many things are created and how many things are done. That's that. So that's static methods and static variables. So remember, static member variables must get initialized right. Usually, you initialize this one in a CPP file, right? At the top of the CPP file, you actually initialize that one, so it actually gets generated in that one. And that's that. It's simple and straightforward. Okay? Questions on this? Suggestions?
So this env, is it still private? Like
Oh yeah, everything. Again, static variable, static member functions. Their lifetime is the lifetime of the executable. The visibility is like a regular variable. Wherever it's visible, that's got to be visible and nowhere else. Okay? It's the exact same thing like a function. All right? Any questions? You want to take a 5 minutes break? Anyone? Break? All right. Okay. So please remind me to resume recording afterwards. So go through fundamental types. At the beginning, these things, go through all the types and please read them. These are all concepts telling you what is the size of a byte, and now what is the size of a long integer, what are the different types that we have, and all stuff like that. So please go through them. I don't want to waste our time going through all these things. Precedence of the operators and like what is each. Please go through them. You have to go through them one by one and see what they are. It's just a waste of time if I want to go through it. So I'm not going to waste time. Those are the things you are supposed to read. The auto keyword. The auto keyword is when you want to create a variable, mentioning it. So let me put this thing away. This is CP static attribute and methods. What is a method? What is a method? A member function, right? What is an attribute? A member variable, right? But C++ refers to as member functions and member variables. That's C++. But object orientation is attributes and methods, remember that, okay? So yeah, so auto essentially, when you are creating a variable and you're initializing it, when you are creating an object and you're initializing it, instead of writing the name of the object to create a variable reference or whatever you want, you can write auto. Essentially, from what is being initialized to, it recognizes what to create. Okay? So if I say over here auto, I set to 0, from 0 it knows it's an integer because that's a literal value. If I say over here short, s is equal to 10, and I say auto, a is equal to s, now a will be a short. Okay? It is very important for our future stuff. Okay? For now, just know that it happens, and it creates makes many things possible when the time comes. Okay? In OOP345, I think they mentioned it, but I said completely forget it and never use it because we have absolutely no use for it. But in 345, as I'm going further in lambda expressions and things like that, you will see that it is actually necessary having something like this, because sometimes the type of what you are having at right side is not known. You cannot write it. Or what you have at right side is a template that you don't know which shape or type is taking. And you want to create a reference or a variable or a copy out of it. And it's impossible for you to know. Based on different logic, it may change. And because of that, auto comes very handy. And sometimes it's just easier, okay? You have a type that is this long instead of actually, for people at home, I was actually showing something very big. Anyways, but it's very long, and instead of actually writing the whole thing, you just write auto and initialize it to something that already exists. So keep that in mind. We make this smaller. All right, so that's auto. So I is int, a is short. Okay, now, if I write something like auto, k is set to 10u, and what is k? An unsigned integer, right? Just bear. So this is an unsigned. Yeah. And same thing for like if I have over here double foo, and in here it's returning 1, 2, 3 point something, something like that. If I write over here auto, D is set to foo. Now D is double, right? Are we okay with this? It's clear, right? It doesn't have to be, or if I have class employee and I write auto nah, I can't do it. I have to create this. Forget it. Never mind. But anyways, if it's a class, it's going to be a class. It's going to be an object of that type. Doesn't make any difference. So that's auto. Okay. Let me show you something. First of all, what is sizeof? Anybody knows what sizeof? Anyway, you know what sizeof is? The operator sizeof. You don't know what is it? You have an operator called sizeof. Yes. So you can pass it to the lady behind you. So the sizeof tells you what is size of anything in memory. Okay. So I can have I was changing the wrong file. Yeah, so I can say size, I can say cout size of double. So I put a type over here. And obviously, when I run this, it tells me exactly how much a double takes in memory. That is 8 bytes. Are we OK with this? All right. And then in here, I'm going to write struct coordinate. Now I can actually say cout size of, and the size obviously is going to be size of 2 doubles, right? Which is 16. Are we OK with this? All right. Common mistake. I'm going to write integer A10. If I say, and it's not only that, I can actually have something like this. I can say coordinates C, and I can go cout size of C. So it could be either an object or a type of an object. It's going to be the same, absolutely no difference. Are we OK with this? So it's the same, and it's going to be 16, right? Now, if I say cout size of A, the answer will be 40. Why? 10 integers. Each integer 4 bytes. That's how much? 40, right? But please pay attention to what I'm about to write. So I'm writing a function to print, I don't know, I less than size and I plus plus. I just want to print few things. Size. And I'm going to go cout. Are we OK with this? So I'm just printing an array, right? You OK with that? All right. Now, I don't care about that I'm printing an array. I just want to show you this. So let's put something in here first. OK? And the rest will be 0. You know that, right? So now in here, if I say something like prn, A and 10, we know that it's going to go, right? Any problem with this? OK? So if the size of is telling me what is the size of the array, why do I need to pass the size again? Can I just say over here, and it tells me it's 40, and I divide it by the size of integer, and I have 10. I can do the math, right? You follow what I'm saying? In here, we said that when I said size of A, it gave me 40, correct? If an array is passed over here, I can simply say size of array divided by size of int, and then I'm going to have 10. That is the size of the array, right? So why am I passing size? This is the reason. I'm going to print it so you can see what is the first thing over here. This is something that I have to write the code for you to remember, because this is a common mistake for rookies. What is the value that is printed over there? 8. Is it 8 integers? Is it 8 bytes? No. It's the size of a pointer. When you pass an array to a function, the array is not passed. Only the address of the array is passed. So no matter what you send, the size is always size of a pointer. It doesn't matter if it's an integer, it's 8. If it's an employee, it's 8, because pointers are all same size. It's the target of the pointer that is different, right? So sizeof for arrays only work in the same scope. You pass it somewhere else, it's not the same anymore. Do I make sense? Are we okay? At home people, are we okay? Are we okay? All right, yeah, please remember that. This is extremely important. Now, next thing is that sizeof is not that simple. Sizeof becomes extremely tricky. Sizeof becomes extremely tricky. I don't know why am I doing that, but anyways. So look at this. Look at test 2 and test 3. They all have character doubles and integers in them, right? But in different order. You see that? Now, not to clutter this, I'm just going to remove everything else, and I'm only going to print the tests. And I don't need the full thing in here. When I run this, this is what happens. Take a look. The sizes are different. One is 24 and the other two is 16. But take a look. They're all the same. Character double int char. You follow? What the heck just happened? It's called alignment. Okay? It's called alignment. The computer is not capable when a computer is looking at the address of anything, it starts from the beginning and keeps going to the size to find which one you're talking about. If I want to see the third double, it jumps 8, 8, 8 to go to the next double. That's why doubles must have an address that is divisible by 8. A double cannot sit an address 7. It must be 8, 16, and it keeps going like that. An integer must sit at address 4, 8, 12, 16, something that is divisible by 4. Now, if I put a character first, character sits at address 0, right? Therefore, the next address is 1, correct? Now I want to put a double. Compiler says, I cannot put a double at 1. So it keeps going to the next available address that is divided by 8, which means double, the address of character will be 0, and double will be 8. And there are 7 bytes unused garbage in memory, just because you didn't order them properly. And the next one is an integer. At double is divisible by 8, correct? So an integer can always come after a double, because 8 is divisible by 4, correct? That's why whenever you are creating a structure, always set all the variable in a descending order to have the smallest size for your structure. Got it? Got it? The first one, character, can sit at any address, right? So when it starts from 0, correct? So C is sitting as address 0. Now if I want to put the next variable, what's going to be the address? 1, correct? Can double sit on 1? No. So it keeps going like that, keeps going until it reaches to 8. Now 7 bytes are fragmented over here. So double goes to the next 8, so that there are a total of 16 down to here, correct? And then you have a 4. 16 plus 4 is 20, right? But if it makes it 20, if I want to create an array of structures, of tests, the next one, when it sits, it must make sure that everything is again at the right address. Therefore, it has to add another 4 garbage after this. It becomes 24. Didn't explain properly, did I? Yes. It's a very difficult thing to... Oh, go ahead. Correct. Mm-hmm. It's not big. It becomes very complicated. I'll explain in 2 seconds. So for the first one, I have, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and I keep going like that, right? Pardon me? Oh, how can I change it? Darn it. Can I? Settings, settings? Camera set. I remember someplace was mirrored. Darn it. Let me change the video. Let me see, maybe the other one is not mirrored. This is a... Why it's not showing? Oh, where's that camera? Okay, there he goes. Let me see if I can actually bring the camera in. It's not showing the camera. Darn it. Now I have to go over here. I have 5 minutes. How do I do that? I can't. I have to have something. There's something over here. Funny thing, it was never like this before. Now it's like camera, related settings. I can ask, but anyways, I don't know what to do. So anyways, please try to, you cannot even, I have an awful handwriting and it's reversed too. But anyways, I'll try to fix it later on. But anyways, you start from 0 and you come down over here. So this is where your character is sitting, right? And the double has to sit over here for 8, right? So it comes right down to 16. Is that correct? And the integer is sitting over here. 19, 20, 21, 22, 23, 24, 25, 26, 20, 27, 28, 29. So it starts, so this is where integer sits. So this is down to 16. Integer sits over here, comes down over here, and ends over here, right? And now if I create an array of array of test ones, the next character must sit over here, right? And now, next double should go 1, 2, 3, 4, 5, 6, 7. Is this a coefficient of 8? No. Because of that, compiler has to, so it wasted this space, right? In here, it has to waste another 4, so the 0 sits over here, and the next one is aligned. It's a difficult, very, very difficult thing when the number of variables go up and down and get mishmashed. It's hardware, but language has to comply to it. Language complies to it because of the hardware. Okay? Now, we have you don't have to think about this. You don't have to worry about this at all. Why? Because we have something called, all these things are automatically taken care of when you are creating an array. The computer will set it up by itself. The program, the language will set it up automatically. You don't need to worry about it. But to use less memory, you have to always remember to sort it in a descending order. And you can, the funny thing is that sometimes, like if I create a structure of 2 doubles, although the size is 16, but the structure doesn't need to be at the address that is divisible by 16, because the members of it are all double. So the alignment of it is 8. Because any place you put a structure with 2 doubles, all the doubles will sit at an address that is divisible by 8 anyway, right? That's why alignment and sizeof are 2 different things. If you check align of, it tells you what address is valid for this. If you say sizeof, it tells you what is the size. And you can even force the compiler to align a structure to a specific thing. You have a structure that is 8 bytes. You can say align it as 16. So you can say align as 16. Go through the notes, you will see it. If you go through the notes, you will see. So align of tells you what address this thing will be aligned of. And align as sets the structure to align to a specific thing that it should always be bigger than the size of the structure. Why do we do this? If you want to set series of stuff in a file, for example, and save series of structures in a file, and you have a first structure that aligns at 16, and you have the second one that aligns at 7, and the third one aligns at something else. To make sure that all the records are set properly the way you want, you can actually align the next structures to be aligned in memory to a certain number. Although the alignment is 8, you can enforce the compiler to align it as 16, for example. Okay? Again, you're not going to use this, but you need to know it. Okay? Always, 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 always. Scan it and send it to me. Take a picture and send it, or put it in a post. Anyway, so that's the alignment, and it's 3:15. We have to go. Okay? So alignment is the last thing. Again, the initial, as I mentioned, the initial lecture is going to take long because it's all concepts, and they're difficult things. Please go read them and come with questions. None of you ask a single question. I guarantee if I have a quiz of the previous thing, you're going to go like your OOP345 quiz. Okay? I'm telling you, you have to study. Otherwise, 70% of you will fail. Wake up. Thank you. See you soon. Have a beautiful day, people online.